name is Lisbeth, and today we're going to be going over volumetric analysis. So this problem right here that I have on the board is actually found in the Ebbing and Gamble book. It's going to be number 92. So I'm going to go ahead and read that real quick so you guys know what I'm talking about here. So it says, how many milliliters of 0.250 molar potassium permanganate are needed to react with 3.55 grams of iron 2 sulfate? The reaction is as follows, and then they give you this reaction. So I went ahead and wrote down our givens. They told us that we had 3.55 grams of iron 2 sulfate and that our molarity for potassium permanganate was 0.250. And we were trying to find the volume of this. So the first step is to remember what molarity stands for. Molarity is also, we can say, that this is just moles per liter, right? So that means I have 0.250 moles in 1 liter of this solution. So this is going to be very important as we go along with this problem, because this is going to be a very important conversion factor for us. So here is my thought process, right? A lot of times we look at our problems and we don't really know where to start. So usually when we're giving grams and molarity, the very first thing you should do is try to convert these grams to moles and see what else you can do. So let's do that first, all right? So we have the 3.55 grams of iron 2 sulfate, and we're going to go ahead and convert that to moles using the molar mass. So 1 mole on the top, and the molar mass for iron 2 sulfate was found to be 151.908 grams of iron 2 sulfate. So I got this number just by adding 1 iron, 1 sulfur, and 4 oxygens, okay? So now, sometimes we just want to go ahead and use this, convert to liters, and that's it, right? However, this belongs to potassium permanganate, and this belongs to iron 2 sulfate. So first I have to convert from iron 2 sulfate, the moles of iron 2 sulfate, to the moles of potassium permanganate. So how are we going to do that? Well, if we think back to our limiting reactant problems, the way to convert from a mole of a substance to another mole of another substance, we can do that by using the molar ratio in the balanced equation. So I'm going to go ahead and put moles of iron 2 sulfate on the bottom. And I'm going to be moving towards moles of potassium permanganate. And the reason I'm moving towards that is because I see volume over here, and I'm trying to find volume. So I'm trying to head in that direction. So moles of potassium permanganate. Now we have to see what the ratio is in the balanced equation. So for here, we have 10 moles of iron 2 sulfate, and we have 2 moles of potassium permanganate. So that means it's a ratio of 10 to 2. Now that I'm in moles of potassium permanganate, I can use the molarity to convert to liters. So now again, since this is on the top, it'll be on the bottom, KMNO4, and we're going to have 1 liter of that solution. And our molarity was 0.250. Right? So now that I'm in liters, I'm 1 step away from having our milliliters, and then we'll be done, right? So here I can put 1 liter, and we have 1,000 milliliters. You can also write it as 10 to the -3 down here, liters, and 1 milliliter. It just depends on what your preference is. So now let's make sure all of our units cancel before we plug that into our calculator, right? So here I see grams of FeSO4 will cancel. I see that my moles of FeSO4 will cancel. I see that my moles of KMNO4 will cancel, and my liters, and I'm left with my milliliters, which is exactly what I wanted. So, woohoo! All right, so when you do the math, you actually find out that you get 18.7 milliliters of KMNO4. So what this means, like, we always have a reason for doing our math in chemistry. We don't just do it to do it. This means that in order to be able to react with 3.55 grams of iron 2 sulfate and have this molarity, we need to have 18.7 milliliters of KMNO4. So if you're trying to, it's just a conversion between this to this. So for every 3.55 grams of iron 2 sulfate, we are going to need 18.7 milliliters of potassium permanganate. And that's basically how you do a volumetric analysis.